Alrighty, we are going to work on the assignment for transforming functions. But if you have not seen any of this information and you're trying to do this assignment, you need to go backwards because there is a lot of information here. In fact, there's information here that has been erased and then like redone because I did more information. Okay, so let's do the assignment. Number 1, we are describing the transformation that goes from F to G. So if you just had regular old F is X and you now had this, that would be a reflection. And that's all you need to say. Number 2, if you had regular old F and then you did this, that would be a vertical shift up 7. Or you could really have just said, you go up 7. I'd be happy with that too. How about this one? You have this originally, then what is this doing? This is stretching by a factor of 6. Stretching because that's 6 and not a fraction. And it's also not reflecting because 6 is positive. So if you just heard me say a few other things like clarifications, there you go. Number 4, if this is what you had to begin with, and now you're here, well, let's see, you had positive 1, but to get to plus 4, you had to have done a vertical shift up 3 more, because you were already up 1, but now you've gone up 3 more. Let's see, given that this is f of x, they want you to graph these functions and then label them. So here's what I want to do. I'm going to graph 1, 2, here, hang on, I'll do the colors I'm going to do. 2, 3, 4, and 5. I'm going to graph all 5 of these functions just so that we can kind of see all the comparisons. So here's the first one. Our y-intercept is 1, our slope is 2, so here comes the blue function. Like that, I believe. I say I believe just because I'm trying to make it like perfect. So this is f, because it wants us to graph all the lines and then pretty much label them. So there we go. So what would happen if we added 3 to it? Well, we would get 2x plus 1 plus 3, which is 2x plus 4. So here's what happens. We shifted the blue line up 3. So 1, 2, 3. And if you're like, I don't want to think of it that way, okay, I guess you don't have to, but notice our y-intercept is 4 now, right? The slope is still 2, so it looks like this. Let's get our graph on. Here we go, just like that. And if you're like, hey, that's kind of parallel to the blue line. Yeah, it is parallel. That's just like bonus info though. You don't have to actually do anything with that. This is 2 times 2x plus 1. Well, that would be 4x plus 2. So if you're like, oh, I'm not really sure how that would have changed. We multiplied the output by 2. This is a stretch, which gets us closer to y. So here we go. We have our y-intercept of 2 right there. Our slope is now 4. So up 1, 2, 3, 4 over 1. I'm also going to go down 4. Let's see, 1, 2, 3, 4 over 1. We'll do it one more time, 2, 3, 4 over 1. So that I can just make it as pretty as I possibly can. Like that. And I'll do it one more time just to go through and off the edge of the graph. I haven't been labeling this, so here the red one is G, the green one is H. And if you're like, I don't really see how this is working, see how the blue line was our regular line? The green line is definitely closer to the y-axis, right? And if you're like, what's the y-axis? You're killing me. That's the y-axis, right? Okay. Let's do this one. If our original f of x is 2x plus 1, and we put a negative out front, then now we have negative 2x minus 1. Okay, so our y-intercept has gone crazy. It's now down here at negative 1. Our slope is negative 2. We're going to go down 2 over 1, down 2 over 1, just like that. Okay, let's get our graph going. Just like that. Okay. That is a reflection over the y-axis. It's a little tough to see because of kind of the other lines, but it definitely is reflected. I mean, just think about the blue one only. The blue one's like this. Imagine if we were to flip it over. It'd be there and 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 there. Okay. Last but not least is f of x minus 2. Well, this one's going to be another vertical shift. If we had 2x plus 1 and then minus 2, we're going to get 2x minus 1. So it's going to overlap that y-intercept, but the slope is still 2. So up 2 over 1, up 2 over 1, up 2 over 1, just like that. And here comes our graph, like that. Okay. And this one was N. All right, there is page 1. Page 2. Use the graph to determine the function rule for f of x. Okay, well, we have a y-intercept of negative 4, so you know me, I'm going to go ahead and write negative 4 because this is y equals mx plus b, and our y-intercept is negative 4, so I'm going to write negative 4 right there, yeah? And then our slope is raise 1, 2, 3, run over 1, 1, 2, 3, so that is 3x minus 4. Now, it says, let g of x be a vertical translation 2 units down. So if we need to move down 2, we're going to do that. And it ends up looking like this. And we don't need to graph it. Oh, yeah, we do. So let's do that. Well, it's going to be a little tough because we are now off the graph, so to speak, as far as with y-intercepts. But there it is. And the slope is still 3, so we're going to go up 1, 2, 3 over 1, up 1, 2, 3 over 1, up 1, 2, 3 over 1. How about that? So let's get our graph going here. And again, it is parallel because we have the same slope. We just shifted it, right? We translated it. In fact, I've been using the word shift a lot. Sorry, shift and translate are the same kind of idea. Use the table to determine the function rule for f of x. Hey, look, that's a y-intercept. So again, y equals mx plus b. I have positive 5. And then my slope is my x's are going up by 3. My y's are going up by 6. So that would be a change in 6 over 3, or 2x plus 5. Now, be a vertical stretch by a factor of 2. Well, here is my original, and if I want to stretch it by a factor of 2, I do that, okay? Now, I mean, I guess if you want to write out the final answer, it's 4x plus 10. So either one of those is perfectly fine as an answer goes. Let f equal 3x minus 2. Use the given function to describe the listed transformations, then write the equation of the transform function as g of x. So first of all, 2f of x would be 6x minus 4. F of x minus 7 would be 3x minus 9. Negative 3f of x would be negative 9x plus 6. Oh, I'm done. Sorry. All of these should go here. Moving on. Oh, not moving on. I didn't describe the transformation. So let's do that. I'll just do it here. So this is a stretch by a factor of 2. And you can word that differently, but just know that, like, if I were to say stretch by a factor of 2, I mean, that's what just happened right here, right? This one is a vertical. I'll start using translation now that I've reminded myself to do so. Translation of negative 7. Or you could also just say down 7. I mean, that works. And then this is also a stretch and a reflection, or flip. If you say flip, you're good, by a factor of 3. I'm going to say negative 3, because even though this part, that reflection, kind of implies that it's negative, let's just go ahead and tell the world, hey, it was negative 3. Okay? Okay. A car rental company rents cars for $50 a day. The function f of x equals 50x represents the daily rental fee for x days. And I'm going to go ahead and point that and highlight this in blue because, oops, I'm going to select the highlighter first. Daily rental fee, just so that I've got it clear in my mind what's what. Daily rental fee equals 50x. Okay, the company decides to add on a one-time $15 cleaning fee. Add on a one-time $15 cleaning fee. Write the function g of x, which given the new cost per day as a transformation of f of x. How would the graph g of x compare? Well, I'm assuming that it's not just a one-time cleaning fee ever, meaning if you come back tomorrow, you don't have to pay the 15 again. So I'm going to go with it's like this, and this is the new piece of info. Because, and like, let's prove this to ourselves. So we have X, we have Y. So if you came in on Monday and you wash one car, it's going to be $65. And then if you come in for 2 days, you will have paid, let's see, $115. So how's that different? Well, let's go with like our original, we'll call it F. You would have only paid 50. You would have only paid 100. So it looks like, and then here just to keep kind of proving this to ourselves, so you did 3 days, that's 150 plus 15, that's 165. If you did 3 days in the old model, it's just 150. So actually, yeah, that is a one-time cleaning fee of $15. You don't have to pay it every day. So how would that change the graph compared to that of f of x? It is a vertical translation 15 up. If you want to be kind of specific with it, it's that you have, I mean, you could also say, hey, listen, you told me what it was. It was adding $15 for one time. So anyway, there we go. The graph shows the function f of x. Begin by writing the equation for f of x. You got it. So we have a y-intercept of 1. Y equals mx plus b. We have y equals something, x plus 1. Let's find our slope. Looks like it's up 2 over 1. Yep, down 2 over 1, so that works for me. We have a slope of 2. Write the equation of gx that would translate the graph vertically. So here's g of x. G of x, I mean, we could write it like this, f of x plus k. If they're being a little bit more specific, I guess we could do this, like that. And then write an equation for h that would change the steepness of the graph. Explain your reasoning. So h of x could also be like a f of x, where a is greater than 1. Or again, we could do this, h of x equals a times 2x plus 1, where again, a has to be greater than 1. So what's our logic here? This makes a vertical translation. And then also same thing here. This makes a stretch. And a stretch, if it were to change the steepness, so I guess it just says, it just says change the steepness, period. So let's actually adjust this. It's not that it needs to be greater than 1 now, it's that it can't equal 1. Because if it equals 1, we have not changed the steepness at all. So really that's a stretch or it's a compression. Okay. Over here, last page, yeehaw, graph the function, compare the graph of f of x, the absolute value of x to what we've got. Well, if you like, one thing I have been in the habit of doing when I was your age, and also just now as a teacher, I graph my parent function just to remind myself what the heck am I dealing with, and then to compare afterwards. You don't have to do that, but, it might help. This is a horizontal shift, horizontal translation, as I have tried to be correcting myself, over positive 3. Why is it positive 3? Because it's normally written x minus h. And if you plug in a negative 3, you would get plus 3. But we have a regular negative 3, so we must have moved to the right 3. So now let's graph it there. And there, if you noticed, I did my kind of slope while I was talking because we didn't change the slope. Nothing out here changed, right? Right. So it's the blue one. Check. Moving on. Number 2. There's our vertex, just like the parent, because we didn't move left or right. We didn't move up or down, right? We instead have changed the steepness. We have changed it to a vertical stretch. And if I were to try and stretch it anymore, I'd be off the graph. So here we go, like that. Done. Number 3, we have a reflection and a compression. So we reflect, meaning now we're going down. And what we're going to go down is we're going to go down 1 over 2, down 1 over 2, down 1. Oops. Oh, yeah, I did it right. Down 1 over 2, down 1 over 2. Just like that. So let's graph. Like that. Done. Now we got a combination of things. This is moving left 2. This is moving down 3. And if you're like, what do you mean left 2, down 3? I mean, our vertex is usually right there, but not anymore. We are moving it left 2, down 3. And now it's just like it was, that our slope is 1 in this direction. Our slope is negative 1 in this direction, okay? Let's get our graph going like that, just like that. All right, write an equation for h of x that represents the given transformations of our regular old parent function. Horizontal translation, 7 units right. So right is positive. So we actually end up doing negative. Why is that? I've said it a handful of times. We usually write it x minus h, right? So if you were to move it to the right 7, that would be positive 7. And a positive 7, when it goes in here, will look negative. Okay, vertical shrink by a factor of 1/3 and reflected. Just like that. Why is it that way? Because a shrink or a stretch or a compression, that's this part out front. And then by the factor of 1/3, well, it's specifically that. And then it's reflected, that is the negative. So there's 3 little arrow explanations for that. There's the whole thing on transforming functions. Let me know what questions you got.